Hi everyone, my name is Annika. I'm part of the Data Science Discovery team. In this video today, we are going to be doing a question on conceptual confidence intervals. So let's go ahead and get started. So here it says, as part of a study to monitor the health of children in Illinois, a random sample of health records of 1,000 children was chosen from all children, right? So it says there's these many children in the population, right? The average weight of the children in the sample is 56 pounds and was also calculated. We also calculated standard deviation. Using this data, we found a 95% confidence interval, right? So here it says, if we increase the size of the sample and the standard deviation remains the same, what will happen to the size of the confidence interval, right? So if we increase the size, and here I have kind of written out the confidence interval formula, right? Is your sample mean, here is the sample mean, right, plus or minus the z-score times your standard deviation of your sample divided by square root of n, right? And this is what we call the standard error, right? Because it's the standard deviation of your sample divided by the square root of n. And here you can kind of visualize it, right? If this here is your lower bound of your confidence interval, and this here is your upper bound, right? The distance between your sample mean and your upper and lower bounds is basically going to be that margin of error, right? So here in the question, if it's asking us that if we increase the size of the sample and the standard deviation remains the same, what will happen to the 95% confidence interval, right? So the size of the sample increases and S remains the same. So this means that the denominator will basically increase, right? Which in turn will make the entire fraction here smaller, right? And therefore the margin of error will also become smaller, right? So this means that our margin, the distance, right, between the sample mean and the lower and upper bounds, this margin of error here will basically become narrower, right? Because our n increased, right? This standard error is basically smaller, and so therefore the z times the smaller standard error will result in a smaller margin of error. So this means our confidence interval will actually become narrower. Now here it says, if we double the size of the sample, what will happen to the size of the 95% confidence interval? And notice for all these problems, we're not actually calculating anything, right? This is the kind of advantage if you conceptually understand what confidence intervals are about. You know what factors can, narrow or widen the interval at hand, right? So here, if we double the size of the sample, right, this means that, again, similar to the last problem, this n will increase. So this standard error should decrease, right? But here we're kind of missing a key role about, or a key fact about our standard deviation of the sample, right? We don't know if it's going to stay the same or not, right? If the standard deviation is the same, but our n doubles, right? So now we're dealing with 2n, right? This in turn will lead to a smaller margin of error, but we don't know if this standard deviation is going to increase or decrease, right? So we cannot make this assumption because we don't know if the standard deviation will stay the same, right? This fraction might increase and might decrease depending on the numerator as well. And if we don't know that, we cannot make any, assumptions or I guess conclusions about the size of the confidence interval. And then here, if a second identical experiment was done with the same number of children and they found a larger standard deviation, what will happen to the size, right? So here we're dealing with the same n and the same number of children, so same sample size n, but there's a larger standard deviation, right? So what does this mean? This means that the sample standard deviation is actually larger, right? So and n stays the same, so this fraction will increase, and in turn this margin of error will actually also increase. So this means kind of the distance between your lower bound and your sample mean is actually going to increase. Your interval will actually widen, right? Because your standard deviation increased. And if you really think about it, this makes sense, right? Standard deviation is the, average distance, the distance from of all of our observations from the mean, right? So if we have a higher sample standard deviation, this means our data varies more, right? So this means with higher variance, right, higher standard deviation, your general confidence interval will actually be wider because of just how much your data is varying even more, right? So if you think about it also intuitively, this makes a lot of sense. So we can see here that basically the size of the confidence interval will always become larger given that our standard deviation has increased, but we have the same sample size, right? If we didn't have any information about the sample size, then we couldn't really assume anything about the size of the confidence interval. But here, since we have that, the fact that n remains the same, but the standard deviation of our sample increased, we can make this assumption or this conclusion. So I hope this video was helpful. If you have any questions, let me know, and I'll see you next time. Bye.